13% of all Americans suffer from sleep apnea. A researcher suspects that a different percentage of those who live in the inner city have sleep apnea. Of those 407 people from the inner city, 53 of them suffered from sleep apnea. What can be concluded at the alpha is equal to 0.05 level of significance. So in this example here, we're talking about proportions. We're talking about a proportion of 0.14. That is what is being stated as the historical value. So we're saying for the null hypothesis, we're saying that the proportion of people that suffer from sleep apnea is 0.14. But then someone is challenging that. They're saying that they think it's a different percentage. So in this case, they're not saying that they think it's greater than or less than. They're just saying that they think it's different. So that means this is going to be a two-tailed test, because they don't care which direction it's in. They just think it's different, not necessarily that it's higher or lower. So when we set up our alternative hypothesis, we're going to say that the proportion is different or not equal to 0.14. This is what the challenge statement is. Now, in order to use, so when we're using proportions and we're running a hypothesis test, we want to use one prop z-test because we're doing one sample. But in order to use the normal distribution to approximate proportions, which is really a binomial distribution, we need to check to make sure that the sample size times our p is greater than 5. Remember, P is our proportion for success. We also need to check that our sample size times Q, which is our proportion for failure, is greater than 5. And in this case, it is, so that we can use the one prop z-test. So we're doing proportions, but we're using the normal distribution to approximate that, which means we're using z's, because we're using the normal distribution, which means when I go to find my critical value, I'm going to do inverse norm because we're using the normal distribution. Okay, so we're going to do one prop z-test. So I'm going to go to stat, over to test, and I'm going to scroll down and look for one prop z-test, which is right here. It's my option number 5. I'm going to hit enter, and then I'm going to put in all of my information. It says that the P should be 0.14. And the number of successes in this, it says 53 of them suffered from sleep apnea. So even though this isn't a positive connotation, we know that what we're looking for is how many had sleep apnea. So we have 53 successes out of a total of 407 in the sample. So my sample size is 407. Now, this is a two-tailed test because we're using the do not equal sign because we're just looking to see if it's different in either direction. So I'm going to use the do not equal sign here. I'm going to come down and I'm going to hit calculate, and I'm going to get all the information I need. Okay, so our test statistic, that's our very first value here. So it's going to be z because we're using the normal distribution here to approximate the binomial distribution. So we have z is equal to, and our test statistic is negative 0.56. So negative 0.56, and then that would be 86 because we got to round it to 4 places. The p-value down here is 0.5697. Okay, so when we go to find our critical value to come up with our rejection region, because we're using the normal distribution to approximate the binomial distribution, we're using z's, which means we've got to use inverse norm. So this is going to be a z for my z critical. So I'm going to go to second vars. I'm going to go down to inverse norm, and I'm going to tell it to the area that I need. Now, this one's a little bit tricky because it's two-tailed. When I draw my picture, we're doing a 0.05 level of significance. Because this is two-tailed, that area needs to be split into both tails. So when I add the two tails together with that area, I should have a total of 0.05. So I got to split 0.05 in two so that it's split between both tails. So the area that's going to be in both tails is 0.025 in this tail and 0.025 in this tail. So when I add it up, I get a total of 0.05. Now you only have to split it between the two tails when you have a two-tailed test. If this was a right-tailed or a left-tailed test, then that whole area of 0.05 would go in one tail or the other. So my rejection region is going to be split between these two tails here. So this is my rejection region. Now, I got to find my cutoff points here and here. So I'm going to put in my area as 0.025. Whoops. Delete. Okay, so there's my area, 0.025. And of course, my mean and standard deviation here is going to be 0 and 1 because we're doing the standardized. And then I'm going to go down and paste it and see what that is. So my critical value, my cutoff point on this side is going to be negative 1.956. Oh wait, 95, yeah, 0.96. Because this is going to force that to round up to a 6. And so on this side is the left side, so we're using the negative. On the right side, we're going to use a 1.96 positive on this side. So when I go to check to see where my test statistic falls, here's my test statistic. My test statistic is negative 0.5686. So let me get a different color here so it's easy to see it. So when I plot this on the graph, negative 0.5686 would fall somewhere in here. It's negative, so it's going to be to the left of 0, but it's not as small as the negative 1.96. It's not past this area here. So it falls in this white area, which means we're going to fail to reject, or we're not going to reject. Don't reject. HO. Because it does not fall in the rejection region. Now, when we put in our critical value here, because it's two-tailed, we have to specifically look at which tail we're looking at. Until we see what that test statistic is, we don't know which side we're going to be looking at. This test statistic is telling us we're looking at the negative side or the left tail. So we're looking on this side of the graph, which means when I put in my critical value, I'm going to put it in as negative 1.96. So when you're doing two-tailed, it could be a little bit confusing, but what you need to do is pay attention to the test statistic. That's going to show you which side you're going to be looking at when you're looking at a two-tailed test. Okay, so here's my critical value of z is negative 1.96. Now, in this case, because it does not fall in the rejection region, we're going to say fail to reject the null hypothesis. Now we're going to look at the p-value. My p-value is 0.56 0.97. That was up here. And since that is greater than our alpha level, which is 0.05, when our p-value is greater than our alpha level, we say do not reject. So that's good. We get the same conclusion as what happens when we did our rejection region. We should always get those two to match. So in this one, we're also going to say fail to reject. Now, because we are not rejecting the null hypothesis, that means there is not enough evidence to support the alternative hypothesis. So we're looking for the statement that says there is not enough evidence to support that it's different than 1 point or 0.14. That's this one here. There is not enough evidence to support the claim that Americans suffer from sleep apnea. That proportion is different than 0.14. So we're going to choose this one here.